Okay, so this is the third page of our notes, right? We're gonna write on the first pink one. So 1.1. Oh, sorry, 1.1.2. 1.1.3 is we're gonna do functions. Okay, inverses and compositions. Okay, inverses and compositions. That's the third piece. Okay. And we didn't start this yesterday, so we're a little behind the other classes, and we had a little story time, so we're gonna have to go pretty quickly, okay? So, functions, inverses, and compositions, all right? What? Okay, so functions, okay, well, let's first talk about inverses. Okay, what do we know is a function, first of all? A function is a mathematical process, or you could say it's a relation. Okay? If you guys remember from the first page of your notes, what does it say? What is a function from the first page of your notes?
Function is
a relationship.
One output for every input.
Yes, one output for every input. If I give you an input, you should give me one output, not two. So if I tell you Anthony, then on the other side he should tell me Sammy, or just one though. He shouldn't be like Anthony, Sammy, Anthony, Goose. Then he's going out with two Y's. I mean, he's assigned to two Y's, and that's not cool. So function is a mathematical process or relation that relates one input to one output, or one output for every input. So what does it mean to have an inverse function? Okay? Not the opposite. Opposite in math means negative, right? So it's not the opposite. What's another word we can use? Reverse. I like that. Okay, so reverses, okay, or does. Okay, so should we call it reversing or undoing? Which one do you prefer? Undoing. Okay, inverse is undoing a mathematical process. Okay, so for example, let's draw a little picture here. Okay, if we have a function machine, and if I put in an input, and I should get an output out, right? Output. What does the other machine do? So it also has an input and an output, but first of all, how do we call this machine? We're going to call it F inverse. Okay? You could call it anything else. You could call it G of X, H of X. But we could also say that it's the inverse of F. So the fact that this one and this one are the same, but they're inverses of each other, we use that little -1. It's not an exponent. Okay? You're not raising it to the -1 power. Okay? I'm going to zoom in a little bit for your eyes, for your viewing pleasure. Okay? All right, so in this one, you're going to put, so it's kind of interesting because this guy's input was the other guy's output. And then their output is going to be the other guy's input. So I'm just going to draw it like this. I'm not going to use words even because it could get confusing. It does the reverse or undoes it, right? Okay, so we know some inverse operations, right? What are some inverse, what's an operation? Give me an example of an operation. Okay, like an open heart surgery, that's an operation, but that's not what I'm talking about. Okay, give me, nobody knows what an operation is? That's the order of operations, so that gives you a clue. Give me one operation. Adding is an operation. Thank you, Antonio. What's the inverse of that operation? Subtracting. Those are operations. Give me another operation. Multiplying. What's the inverse of multiplying? Dividing. What's another operation? Squaring. The inverse is square rooting. Okay? All right. Or cubing. The inverse would be cube rooting, right? Those are some inverse operations. Does the order matter when we're reversing something? Yes, order matters, right? So we could have, okay, when we're doing a regular function, what is the order of operations? PEMDAS. So when you're doing the inverse, what is our order? SADMEP. Okay? Because it's PEMDAS backwards. Right? Think about it. If the order of operations is that I put a present in the box and then I wrap the present and put a bow, the reverse will be take away the bow, unwrap the present, open the box, and you have your original present. Right? So if the proper order is parentheses, exponents, multiply, divide, and add, subtract, when I undo it, add, subtract, multiply, divide, and exponent parentheses. So we're going to go backwards. Does that make sense? Make sense-o? All right. So let's have, what's an example? Okay, so for example, yesterday or 2 days ago, okay, examples, we had a function. Remember, what did you do when you put in 4 and you got out 7? What was the function that when you put in 4 you get out 7? Multiplied it by 2 and then added 1, right? And you guys figured out what's the inverse of that operation? Yeah, so the inverse, that's read as F inverse. Can everybody say F inverse? Yes, F inverse of x is to subtract 1 and divide by 2. So those are inverses. Okay? You get me? Now let me tell you something. I could have just called this g of x. Okay? I could have said, okay, these are two functions and they're inverses of each other. And that's correct too. But what I'm doing by calling it F inverse is it's more convenient because it just gives more information because I'm saying it's the same as this function, but it's the inverse of that function. You get me? So that's why that notation is useful. All right, cool. So let's just do an example of what you're going to, this is actually something you guys already learned in Algebra 2. So let's test how well you remember your Algebra 2 stuff. Okay? So let's go ahead and draw a line. Okay? Let's put 2 examples. So we're going to do this. Okay? The first example, I'm going to ask you to find the inverse. Okay, that's the direction. Find the inverse. Okay, here's my function. F of x equals 3x cubed minus 5. Okay, 3x cubed minus 5. Okay? Now let's think about this. Are you guys hot? Okay. I'm not trying to compliment myself. Okay, so all right. Let's think about this, okay? Let's think about this in 2 ways. If you think about this, what am I really doing when I have to take a number and I do what with it first? No, I mean the regular function. What do? I first cube a number and then I multiply by 3 and then I subtract 5. So if I'm going to go backwards, I should add 5, then divide by 3, and then cube, not square root, cubed root, right? So according to our intuition tells us that we should, don't write this down, okay? Add 5, and then we should divide by 3, and then we should cube root. That's our intuition. Can you tell me algebraically what that would look like? X plus 5. All of that over 3 and then? Okay, so that's our guess, what our function should be, okay? But let's figure out, because sometimes it's not that easy. So this is not always going to work. It's easy for when it's a simple function, but you'll see we'll do a more difficult function. So this is just a conceptual way to understand what we're doing. But guess what? If you do algebra, the algebra does it for you. Mira. Okay. The first thing you're going to do is, first of all, rewrite your f of x. F of x gives you the output, right? After you put the x in as the argument, f works on it and pops out an output. What do we assign that output? What variable do we assign that output usually? We usually call it y, right? So y equals 3x cubed minus 5. That's the regular function. But on the inverse function, the input and the output should do what? Switch, right? Why are we switching?
Because we're trying to.
Because in the inverse function, the x and the y, the input and the output should switch. So step 1, switch the x and the y. You get me? Remember that? So let's switch, okay? First, switch. So x equals 3y cubed minus 5, okay? Right here, we already found the inverse function. So in a way, we're done. That's the inverse function. But this is only writing the inverse function implicitly. If you want to get fancy, this is an implicit. What's the difference between implicit? What's the opposite of implicit?
Explicit.
Very good, explicit. In English, what does it mean to say something implicitly or to say something explicitly? Who knows?
Like detail, right?
No, it's not about detail.
Like it shows more.
Implicit is implied. If I say, those shoes are very interesting, implicitly, what am I saying? That I don't really like them, right? But explicitly, I say, I don't like those shoes. That's explicitly explaining. Implicit is implying, okay? Being direct, okay? So implicitly, this is our function, inverse function. But explicitly is when you spell it out where all the x, you basically get y by itself. Okay, so all the x's are on one side and the y's are on the other side. For example, por ejemplo, okay, equation of a circle, x squared plus y, I'm on a tangent right now, so just listen. So x squared plus y squared equals 1, that's an implicit equation for the formula of a circle. But if I want to get y by itself, I would have to subtract x squared on both sides. So y squared equals 1 minus x squared, and then I square root both sides, so y equals plus or minus the square root of 1 minus x squared. Now this is the implicit equation for a circle, but this is the explicit equation for a circle. Okay? You get it?
Yeah.
Where you have y by itself and the x on the other side. That's explicit. So again, this is the answer. This is a function of that's the inverse, but to say it explicitly, we have to do what? Solve for y. Get y by itself. Okay, solve for, don't say just y. Solve for the, because there's more than one y in this picture, solve for the new y. No, solve for the new y. Not the old y, the new y. Okay? Why? Because we want the explicit equation. Okay? Are you guys still with me?
Yeah.
Now, I have a tendency to look at you guys more because of the way I'm sitting. So you guys, if you feel like I'm not giving you enough attention, just holler. Okay? Solve for the new y. Okay? All right. The new me. Okay, so let's get y by itself. So what should I do to get y by itself? Add 5. Interesting that you told me I should add 5 first. Okay? So x plus 5 equals 3y cubed. What do you think I should do next according to what we know? Divide by 3. Okay, why do I divide by 3? Then this cancels, right? So we have x plus 5 over 3 equals y cubed. Let's go over here. Okay, I'm going to write it again up here. What should I do now? Cube root it. You see how the algebra is automatically leading me to do everything backwards? Yeah. So the cubed root of y cubed is y. So y equals the cubed root of x plus 5 over 3, cubed root of it. Okay? So now this is the answer explicitly. Yeah? The function explicitly. Okay, and that's our answer. Now we can say it in one other way to be even fancier. What can we do? Instead of y, what should we call the y? F inverse of x. Because it's not the f of x. F of x already has a name. It's this one. But now f inverse of x is the cubed root of x plus 5 over 3. Okay, good. And guess what? It's what we said it was going to be, huh? We're pretty bad, huh? Cool. Rad, haha, rad. Okay? Now let's talk about this a little bit. First of all, are there any questions on what we did? Pretty much all we did was switch the x's and y's and we solved for the new y, yeah?
Yeah.
Okay, now let's test this out to see if it works. Somebody give me a number, any number.
1,
6,
12,
20,
9, 14, 5.
8, okay, let's do 8. Although 8 cubed is kind of hard. What's a number that we can easily cube? 2, let's do 2. Okay, let's do 2. So f, if I put 2 in, let's see what I get. F of 2, the argument is now, don't try to argue with me. When I ask you for the argument, what is the argument? You say, the argument is that the 2 is bigger. No, that's not the argument. The argument is 2. So that means I'm going to plug in 2 for all the x's, right? So what's 2 cubed?
8.
Times 3? Minus 5?
19.
So if I input 2 into this machine, I get out 19. So if I did this right, if I put what into the inverse? 19, what should I get back?
2.
Let's see. Okay. Put in 19 into the argument of the inverse function. 19 plus 5 is?
24.
Divided by 3 is?
8.
Cubed root is?
2.
Whoa. So it worked, right? It worked. Wait, did we just? Yes. I know, they can. That's okay. Now it worked, but I didn't want to write over it, you know. It works. Wait, did we prove that it works for every case? How many cases did we test out?
1.
Is that a good proof?
No.
No. That's like when you guys will say, oh, I know it works, Sammy did it. Okay, but say just because Sammy did it, does that mean everybody's going to do it? No, so one case is not a proof, okay? How do we prove? Okay, so then that would be 2. You think 2 is going to prove it?
Negative number.
But yeah, you put a negative number. Let's do -2. But then let's say it works. But 2 cases doesn't prove it either. How many cases do you need to prove it?
17.
No, an infinite. Is that going to take us a long time? Yeah. Infinite? Okay, so this is how you prove if it actually works or not. You don't plug in 2. You don't plug in -2. You plug in an x. You actually work with an abstract. That's the whole idea of algebra. You're working not with individual numbers, because up until like 7th grade, you only work with numbers. But your life got complicated when we started putting letters in there. You know why? Letters represent any number, every man. It doesn't just work for you. It doesn't work for you. It doesn't matter how tall or short or white or black or girl or boy. It should work for every man, and that is your X. All right? So let's see if this works for every man, okay? So how can we know? Okay, how can we verify? All right. I like the enthusiasm, you guys. Okay, so this is what we're going to do. We're going to verify. So example 2 is going to ask you to verify inverse functions. Okay, what does it mean to verify something? To make sure it works, to check. Okay, here's a rule. Okay, if F, and I could call it G, but I'm going to call it F inverse. Okay, F and F inverse are truly inverse functions. Then, by the way, when I have an if and a then statement, what is that called? Starts with a C. Well, the second part is the conclusion. The first part is it only works on a certain. Somebody said it. Condition. It only works on a certain condition. So this is a conditional statement. Flashback to geometry. Okay. If F and F inverse are actually inverses, then F of F inverse of X should equal X. And F inverse of X should also equal X. Okay? What am I talking about?
No, I get it.
Te que hablo. You get it? Can you explain what you get?
Yeah.
Okay.
No.
Oh, no?
Yeah.
What do you get?
You put the inverse inside the original.
Yeah?
You get an X.
You put the inverse inside the original and you get an X. Okay? How can you explain it?
And the opposite way.
And also you put the original inside the inverse. So basically they should undo each other. Think of it like this. If if I put something in, I F inverse it. If I okay, let's start with this one. If I do something with my F, but then I mean with my X, and then I undo it, what should I get back? The original thing. If I take a present, I have a present. I put it in a box. I take it out of the box. What am I left with?
A box.
No, the present. Okay. Or we can think of it this way. Okay? Listen to this. I have a baby. Okay? Okay, think of this as a baby inside the mama. But this mama is the baby inside its mama. So there's a baby, a mama, and a grandma. Okay? Well, it's true, right? Where did you come from? Your mom. But where'd your mom come from? Her mom. So, right? Okay? So, all right. So, what's the baby here? The X. If I F it, okay? If I do F on it, if I do F on it, okay? But that result, it becomes a baby of a inverse F. Then in the end, what should I get? The baby should go back and just, you get the baby back, right? Same thing the other way. If I take a baby and I un-F it, but then I F it, in the end, you just get the baby back. Okay? I don't know why you guys are laughing. This is not funny to me. It's just math. Okay? Okay. All right, so let's do both of these examples. And we're getting really small here, so just try to write small, okay? Do your best. It's good for your motor skills, fine motor skills, okay? All right, that's right. Okay, so mira, we're gonna still work with our functions that we worked with earlier. So an example, okay? I want to know what f of f inverse of x is, okay? Now, we're talking about composition of functions now, okay? So, first of all, start with the inside, okay? Start with the baby. What is inside? It's the f inverse, okay? And I think Anthony was doing this yesterday. What is the f inverse? F inverse is which function that we did? We said this is f inverse, right?
Yeah.
So let's put it in. F inverse is the cubed root of x plus 5 over 3, okay? So now that is the mom, or the f inverse, but now this is the baby of the f. It's the argument of the f. So, you guys with me so far? All I did was replace f inverse with what it actually explicitly is, which is this equation. Okay? I just replaced it. But now what do I do with this baby? I have to f it, okay? Original f. What does f do? F does what? F does 3x cubed minus 5, right? So let's write it. 3, but instead of x, write parentheses cube minus 5. Write the whole thing so you don't forget about that 5 later on. But what should go in the parentheses now? What's the argument? That whole blue thing, right? Okay. Okay. So now let's see. According to PEMDAS, where should I start? In the parentheses. Okay, so there's this whole thing, but I can't really do anything here. So this is a cubed root of something that I'm cubing. If you cube a cube root, you undo the cubing and the cube. They undo each other, so they're canceling each other out. So you're just left with x plus 5 over 3. Do you guys see what just happened? Do you see how the little square root symbol, the cube root symbol, and the cube, they went away because they undid each other?
Yeah.
So now what's next? The 3 and the dividing by 3, right? Because in a sense, this 3 is like a 3 over 1, and then this 3 and this 3 kind of cancel out, right? Yeah? So then I'm going to get x plus 5 over 1, which is just x plus 5 minus 5, which equals?
X plus 4.
What's plus 5 minus 5? They cancel, so I get, hey, what I get? The baby! The baby! I put the baby in the f inverse, and then I f'd it, and then I got the baby back. Okay?
Miss, now I know where babies are.
Okay. Alright? Babies are born from un-effing and effing. Okay? So, wait, that only verified one part of it. Let's make sure it really works both ways. Okay? So now let's start with f inverse of f of x. Okay, well what is f of x? The baby here is f of x. What does f of x do? The original f, what is it? 3x cubed. 3x cubed minus 5. Okay, now I have to take that. Now that is the new argument, the new baby of the f inverse. But what does f inverse ask us to do? F inverse asks us to cube. By the way, this is really useful for calculus. It asks us to cube what? It asks us to cube our argument plus 5 over 3. You see how I'm just rewriting that expression, but I'm just using parentheses? Now what goes in the parentheses? The baby, right? The 3x cubed minus 5. You see that?
Yeah.
Okay. According to PEMDAS, what should we do first? Parentheses. Well, I can't do anything there, so then what should I do? This parentheses, does it really matter if I subtract 5 first or add 5 first? Can I associate a property? Can I just do negative 5 plus 5 first? Yeah, so that's just going to be 0, right? So now I have cubed root of 3x cubed over 3. Well, what's 3 divided by 3? 1. Okay, not 1, but 1. Okay.
Cancel out.
Okay, so now I have the cubed root of x cubed, ¿qué no? And what is the cubed root of x cubed? They undo. The baby came back. Okay, so now I just proved that it works both ways. So therefore I prove that these two are actually were correct, and these really are f and f inverse. These are really inverses of each other. What we did here, we just proved it, but think about it. Think about it. Did we just prove it for only the example 2, like number 2, number 19? No, we proved it for any x. No matter what x you put in, that could have been anything, it's always going to work. No matter what x you put in, it's always going to work. Okay, so that's a proof. Okay, so basically what this is, if you take an x and you un-f it, and we were talking about that. Okay, so basically if I put in something, I take the output and I put it back into the inverse, then I should get the original input. Or if I take a number and I put it into the inverse and then I put that output into the original function, then I should get my original. Okay, so it's a loop like that. You get me? Very good. All right, wonderful. Okay, what we're going to do is we're going to do a practice on a slightly difficult, more difficult problem. So please get out your composition notebook, okay? And on a new page or just wherever your next space is, okay? I want you to go ahead and write today's date. What is that? Somebody farting or something? Okay? And write 1.1.3 functions inverse examples. Today is the 10th. Okay. Okay. That's because you're working hard. Not because you're smart. In a good way. Okay? Alright. So now you know what to do. Our steps are to switch the x and the y and solve for the new y. So find the inverse function for this function. The function is f of x equals, it's a rational function. Do you guys remember rational functions from Algebra 2? Rational functions are fractional functions. Fractions. Okay, 2x plus 1 over x minus 1. But you know what? X equals 1 is not included in the domain. X cannot equal 1. ¿Por qué? ¿Por qué no puede ser 1 este x?
It'll be a zero.
Tendremos cero en el denominador y no se puede. Es imposible. Okay, so do you guys know your steps?
Yeah.
First, replace the f of x with what? A y, and then what are you going to do to the x and the y?
Switch them.
All right, go for it. Work with your partner. Do it.
No. First.
This is going to cause you to have to recall your algebra 2 skills. And some of you, or algebra 1 skills. Yes, so every x you see, make it a y, and every y you see, make it an x. Right, you do that, and then you switch, right? Then you switch your x's and your y's. What did you do? What happened to the y minus 1? What happened to the x? Where's the x here? That's not fair. You can't just add it into there and not here. You can't do that. Your next step would not be to add one, subtract one. What are we doing?
Yes.
Good. First step is good. Yes. First step, make this into a y.
I know, I got that part.
Okay, then switch every x into a y and every y into an x.
I have 2x now.
So your goal is to get all the y's together and to get y's here and here. So why don't you distribute that x? Can't do that because there's an x here. Illegal.
Do you multiply
Y minus 1. Yes, multiply y minus 1 on both sides. So that you can.
Wait. We have one of them. That's what I did.
And then distribute the x.
Oh.
Okay, we're going to do this next step together because everybody's having the same question, okay? So, this is kind of scary. Kind of scary that we don't know how to do this. Okay. This is Algebra 1, the latest Algebra 2, okay? Okay. So, by the way, you guys, I'm going to have an SAT class on Mondays after school if you want to come.
Monday after school?
Yes.
This Monday?
Yes. You don't have to come. It's not mandatory. It's optional. Okay. All right. So, it's going to be math and English. All right. So, first we're going to switch the x's and the y. So, x equals 2y plus 1 over y minus 1. Now, remember, what is our goal now? To get y by itself. Okay? But the thing is, I have a y in the numerator and a y in the denominator, so that's the biggest problem to me. I'm not worried about these ones. I'm more worried about the fact that these y's are in a fraction, and I want it all on one level. So what am I going to do? Multiply y minus 1 on both sides. Okay, now notice I'm multiplying it to the top row, not to the bottom. That means you would be dividing it. Okay? Make sure you're multiplying on the top. I would hate it to see you write it down here, which is what I saw first period. Somebody do. Okay. Then why did I do that? The whole point of that is that, by the way, when you see a fraction like this, why don't you go ahead and put parentheses, because that's what's there. It's implied. It's implicit. Okay? All right. So what happens to this? It becomes what? 1, right? Because anything divided by itself is 1, so in a sense it can go invisible. So now I have y minus 1 times x equals 2y plus 1. Okay? Now what am I seeing most? Okay, you guys okay with me now? I mean, you're with me now? Okay, the problem that I see is most of you guys wanted to do what? You saw this plus 1, it bothered you, and you started to subtract 1 on both sides. Why do I not want to do that? Can you just subtract 1 right here and then put it to here? No, this guy is not by itself. It's like in a present. It's like subtracted from y and then multiplied by x. And you can't just say, hey, can I play with you? Can you come out? He's already like deep in the house. So you can't just do that. Okay? So according to PEMDAS, you have to subtract all this stuff. Okay. So again, what's my goal? What's my goal? Get the y by itself. But now this y has to be, there's y here on the left. Now we got it out of the fraction, but now my biggest problem is there's a y on the left and a y on the right. But to make an explicit function, I have to get all the y's on one side and all the x's on the other side. So if I want to move this onto the other side, though, before I can do that, I have to distribute the x. Okay? I'm just distributing it backwards. That's fine, right? That's going to be xy minus x equals 2y plus 1. Now what? Again, my goal is still the same, okay? Math teaches you so much about life. Keep your focus on the goal. Don't get distracted by other smaller and important things. Our goal is to get y by itself. We have a y here and we have a y here. So let's move them all to one side. In fact, I'm just going to move this to the other side. So I'm going to subtract 2y on both sides. Okay? So I'm going to get xy minus 2y minus x equals, that's 0, 1. Okay? But what do I also not want on this side? That x, right? Yeah. So let's move the x to the other side. I could have done that in one step, but just for in case anybody's confused by that, that's 0. So xy minus 2y equals 1 plus x, or x plus 1, same thing. Now I have two y's. But can I combine them? Is there anything I can do to combine them? Kind of. How many x's, how many y's do I have right here? I have x of them, right? I have x of the y's, yes. How many y's do I have here? 2 of them. So how many y's do I really have? X minus 2 of them. If that didn't make sense to you, think about it like this. I could factor out the y. So who's left here? The x. Who's left here? The minus 2. So you could either think of it as combining like terms or think of it as factoring. Okay, but does everybody see that? Factor out the y. I'm going to switch this order. Okay, now I'm getting warmer because now y is almost by itself. And to get it away from this x minus 2, what do I need to do? Divide by x minus 2 on both sides. Okay, so x minus 2 divided by x minus 2 becomes 1. So 1y equals x plus 1 over x minus 2. Okay, and that, my friends, is the inverse function. Okay? Got me? Now, let's just for fun test it out. Okay? Give me a number.
2, 1, 5, 4.
Let's work with 5, okay? 5. Okay, let's use 5. You can't use 1, right? Because 1 will does not work. 1 is not an option. So let's use 5. 2 times 5 is?
10.
Plus 1? 11. Okay, 5 minus 1 is 4. So this becomes 11 over 4. Okay, remember that. So f of 5 is 11 over 4. What's f inverse of 11 over 4? Okay, 11 over 4 plus 1 over 11 over 4 minus 2. Well, let's think about this. I hope you guys know how to do this. How do you make a common denominator? What's 1 as a quarter? How many quarters make 1? 4 over 4. How many quarters make 2? 8 over 4, right? So 11 over 4 plus 4 over 4 is 15 over 4. 8 over 4 minus 8 over 11 over 4 minus 8 over 4 is 3 over 4. Okay, copy, change, flip, sure. 15 over 4 times 4 over 3. The 4's become 1. 15 over 3 is 5. So f inverse of 11 over 4 is 5. And f of 5 up here was 11 over 4. So voila, they are inverses of each other. We checked it for one case, but if we want to check it for every case, we would do the example that we did in the pink. Okay? You get me? Very good, you guys. We did pretty quick. We moved pretty quickly, but I want to do one more example with you. Hold on. But we ran out of time. So your homework tonight is going to be to do 1.1.3 RMP problems. Okay, I know I didn't check your homework from earlier this week, but you never know when I'm going to strike, so have it ready tomorrow. That's on Schoology. I didn't put up the solutions, but the homework hints link is there, and you can find the solutions there. You get me? Please grade your homework and tell me how much time you took on it. Very good. See you tomorrow.